Alright, in this video we will learn about fractional exponents, or sometimes we say rational exponents, because fractions are those rational numbers. Now, in the past we learned about exponents. You know, we would have n to the 5th power, and we learned all about that. And then recently we introduced integer exponents, which began to include negative numbers. So we learned that n to the negative 5th power was the same thing as 1 over n to the 5th power. But now we're going to learn about rational exponents, which will now include the fractions. So for example, we might have something like n to the 2/5 power. And the key to this is that when you look at a fractional exponent, you are looking at two things. You're looking at a power and a root. So that's the key, power over root, power over root. So what I mean is, if you recognize that the denominator is the root, then we could rewrite this and it should be the same as the 5th root. Now this 2 I'm saying is the power, so you could have n squared, or you could have written it this way, with the 5th root of n, and then the whole thing could be squared on the outside. Either way, it means the same thing. Now, if that seems strange to you, take a look at a calculator. Actually, before we look at a calculator, let's simplify this a little bit. Power over root. Let's look at something that we know all about, square root. For example, we know that the square root of 9 is 3, because 9 is 3 times 3. Now, according to this principle, that we could make a fractional power, that would be power over root. If you look at the square root, for example, the square root of n, well, first of all, what's the root? I don't see a little number there like when we have 5th root. So I need you to understand that square root is the 2nd root. We don't show the 2, it's understood, but it makes sense because, like I said, 9 is 3 times 3. So the square root is what you get when you unsquare something. In other words, 3 to the 2nd power, if you take the square root of that, it becomes 3. But that 2nd power, the inverse of that is the 2nd root, so it's the square root. Anyway, so the root is 2. So that should go in the bottom. Now, of course, there's no power here, so it's understood to be a power of 1. Alright, but we just don't show the 1. Right? So, what we're saying is square root should be the same thing as the 1/2 power. So, for example, if we know that the square root of 9, we know that that's 3, well, that should be the same thing as 9 to the 1/2 power. Both of these should be 3. So if you take a look in a calculator, if we were to do the square root of 9, of course that's 3. Now if I do 9 to the 1/2 power, you see that that is 3 as well. Okay, so square root and 1/2 power are the same thing. Now it works for additional roots and powers as well. Okay, cube root. We know that the cube root of 27, let me use something different. The cube root of, I'll do the cube root of 8. The cube root of 8 is 2, because 8 is 2 times 2 times 2. Okay, so the cube root of 8 is 2. Well, that means 8 to the 1/3 power should also equal 2. Alright, so if the root is going to be 3, then that would go in the denominator. And this is like 8 to the 1 power, but we don't show the 1. So cube root should be the same thing as 1/3 power. So just take a look at that one more time. Whoops, wrong button. Okay, first of all, how do you do the cube root on a calculator? If I do To do cube root on your TI-30XS multi-view, you would type a 3 first, and then you would hit second, and you hit this little caret. You see the x root over it, so that becomes cube root of 8, and of course that's 2. So now let's take a look at 8 to the 1/3 power. Okay, so hopefully you're convinced now that the square root is the same thing as 1/2 power, cube root is the same thing as the 1/3 power, and it goes on from there. You could say that 4th root is the same as n to the 1/4 power, and so on. Okay, hopefully you're comfortable that that's true now. Alright, so for right now, we're going to stay much simpler than that. We're just going to rewrite these in exponent form. Now, when you watch these videos, please make sure you are not copying off of me. Alright, if you're, please make sure if you're doing this homework, you should have done the homework by now before you start watching the video. Don't sit here and copy off of me and do it along with me. Do it yourself first, and then check your answers on the answer key that's been posted. And then if you're getting things wrong, then that's why you're coming back here to see where you went wrong. But even then, you should be watching this without a pencil or a pen in your hand. And then once you learn how to do it, go back and still do it by yourself. So if you have a pencil in your hand, put it down. So all we need is power over root. So 7 is the power and 5 is the root. So that's how you would do number 1. Number 2, 6 is the power. We need power over root. So 6 is the power. Now what's the root? It's invisible. I'll give you a hint. It is not a 1. That's an invisible 2. It's the second root. Okay? And of course that would be the same thing as 13 to the 3rd power, because 6 divided by 2 is 3. But we're not asking you to simplify right now. We're just rewriting in exponent form. So for this exercise, you could leave it like this. For number 3. Now this coefficient out here in the front will not change. So we can just leave that 5 out front. So just focus on this part. This is the part that we are transforming. So don't worry about the fact that there's more than one thing in here, except for the fact that you need to put it in parentheses to group it. 4 is the root. So we do power over root, so the power, so that 4 goes in the bottom. Now the power, I don't see any power, so this is like all raised to the 1 power. Okay, so, or you could just remember that 4th root is the same thing as the 1/4 power. And that's it. Don't multiply the 5 times 3 and make 15 order of operations. Okay, number 4. Same thing. Just make sure your 8D is in parentheses, and 6th root is the same thing as the 1/6 power. Okay? Power over root. You know the 6 has to go in the bottom. Number 5. Power over root. So that's 9 over 8. Straightforward. Number 6. Hopefully by now you've just really memorized. Alright, I don't like that left parentheses, and OCD runs me sometimes. Hopefully now you've memorized that square root is the same thing as the 1/2 power. Square root is understood to be the second root. Okay, number 7. So now we're going the other way. We should be able to rewrite a fractional exponent using radicals. So still we have got power over root. So we know that the root is 3 and 4 is the power. So this is h to the 4th power. Or you could have put the 4 on the outside if you wanted to. Okay, number 8. Maybe now you've memorized that the 1/3 power is simply the same as the cube root. Otherwise, you're thinking power over root. 3 is definitely the root. 1 is the power, but I would like you not to write the 1 is understood. Okay, number 9. 1/2 power. I really want you to make it automatic to yourself that 1/2 power is the same thing as the square root. I don't want you to have to think to yourself, oh, this is the power and this is the root, so that would be a 2, but it's invisible. That's too many thoughts for such a simple thing. 1/2 power, square root. Go ahead and get it in your brain directly. Okay, but 5/7, you're going to think, oh, that's the power, that's the root. So 7th root, 5th power. Okay, power over root. Okay, number 11. 1/4 power is the same thing as the 4th root. So hopefully you'll go directly to this. 4th root, 3km. Alright, the 1 does not show up anywhere. I don't want to see any 1s anywhere. Okay. Now, problems like this, these are the ones that take an extra step. We have these two different denominators, okay, and we say power over root. So the way it looks right now, if we just looked at this part, we're thinking, oh, well, that's a square root of n. And if we looked at this part, well, that would be the 6th root of p. But we need a way to write this as just one root. And here we've got two different roots, so that's a problem. So the solution is to get the denominators to be the same. It's similar to what we did when we used to add fractions. And we'll be adding fractions again, so this is a good review. Remember how when you add fractions or subtract, you need like denominators? Remember that? And remember how you used to do that? Well, even though we're not adding these fractions, if we want like denominators, we can multiply. So if I were to multiply this by 3, that would make 6, and that would make it the same. Of course, we have to multiply the numerator by 3 as well. That way, we are really multiplying by 1. 3 over 3 is 1. And multiplying by 1 doesn't really change the value. So this is going to become 3 over 6. Okay, and so 3 over 6 and 1 over 6. So, what am I saying? I'm saying that this problem is the same as having n to the 3 over 6 power times p to the 1 over 6 power. So now that we've made the denominators the same, then we have the same root when we switch it to radical form. So now the root is 6. So we can go ahead and do that. Now we can put both variables in the same radical. Now these numerators will become the powers. So it'll be n to the 3rd power and p to the 1st power. So there's my n to the 3rd power from here, and p to the 1st power, but we don't show the 1. So we just put p. So this should be your answer, number 12. And that's the end of this lesson, this video. The next video will cover rationalizing the denominator and rewriting these expressions in standard form by getting rid of the radical in the denominator. So pick that up on the next video.